recently got a rover kit from Phidgets, and I want to test out what would happen if I were to use a thumbstick to control the rover. Now I want to show you how I did it. If you don't know me, my name is Raheel and I make videos about programming and computer science. This is the first video where I'll be covering a robotics related project, so let's see how I do. So let's take a look at our rover kit. First we gotta make sure to unbox everything. And let's just put some Velcro tape on the robot and the VIN hub as well as the Phidget controller. Flip it over and get one of the two sets of wires, feed it through the top, connect it to the first channel. The red wire goes into the positive and the black wire goes into the negative. And connect the second pair and do the exact same process. Then we have our wire harness, connect the red wire to VCC and the black wire to ground. And then plug in the wire harness to the wireless VIN hub. Then we'll connect our thumbstick to port 3 on the VIN hub and our DC motor to port 5. Then we'll just feed them through the sides to organize the wires a little. Then feed the battery connection through the top and connect it to the wire harness. I'll be coding this in Python 3. To check your version of Python, just write down Python 3 -V. I'm running on 3.9.1. And let's just install the Phidget package. So that would be pip install Phidget 22. Now let's open up a file. So you can open this up in Visual Studio Code or whatever code editor you choose to use. I'll be using NeoVim right here. And the first thing we're going to have to do is we're going to have to import some of the Phidget packages. The first device is going to be the DC motor that we have at the bottom, or the DC motors. Same with the voltage ratio input, which is going to be our thumbstick. We're going to need the Phidget module itself. And lastly, we're going to need to connect to our VIN hub, so we're going to need to import the network. And for testing purposes, we're going to need to import our sleep function from time. And we know this is a wireless VIN hub, so we're going to need to add a server, just using that net library that we just imported. And we're going to use the add server function, or method. We're not going to specify a server name. This is going to be the server address. And then we specify the server port. Then we specify our server password, which is nothing. And we don't have any flags, which is going to be 0. And now we got to assign our left and right motors. So our left motors is going to be the DC motor. And our right motors are going to be a DC motor. Then we have to set them as different channels because the DC motor module has different channels. So let's assign our left motors to channel 0 and our right motors to channel 1. Then we have to actually open the connection. So I'll just do left motors dot open, wait for attachment, and then let's do 5 seconds or 5,000 milliseconds. And then same thing with the right motors. And then we got to set the velocity that they're going to run at. So our left and right motors are both going to run at maximum velocity. And then we're going to make them run at that for 1 second. So we're going to use that sleep function. And then we're going to stop both motors. So let's just copy this code, paste it down here, and we'll turn it to 0. So now you can connect to your Phidget through Wi-Fi. I've just connected right now. And you can open up a new terminal and just run the Python 3 command on your code. Or if you're using an IDE, you can just click on the play button. All 4 wheels should turn in the same direction. So if the wheels on one side are turning in a different direction, then you can just switch the black and red wires on any of the channels and that should fix it up. And now we got to look at our thumbstick Phidget. Let's assign our vertical reading on the thumbstick to the voltage ratio input. And the same thing for the horizontal reading. And similar to these, we have to actually set their channels because there's 2 different channels for the thumbstick Phidget. And the process repeats when we have to open their channels. The different step here is that we have to actually set the data interval, and the data interval is just the rate at which we receive data from the thumbstick, and we want to set that just to the minimum amount so that we can actually receive data as soon as it happens, because then there's going to be quite a bit of delay. So let's just set our data interval to the minimum amount by doing vertical or horizontal.set data interval, and then saying get min data interval. It'll be that value. Same thing with this one. It'll just be, instead of vertical, it'll be horizontal. And we don't actually need time anymore, since we won't be using that in our program. Next, let's write a try except block to accept any keyboard interrupts or any other exceptions that we get. So let's do one for our keyboard interrupt so that we can actually stop the forever loop that we're going to write. Let's do one for any other exception that we get, and we'll just print the exception that we get. And then the last thing we'll do is we'll just turn off, or we'll make sure that both motors stop moving. So we'll set the target velocity to 0. Let's just do some indications that the programming is starting and exiting, just because it will take a second for the fidget to connect over internet. So we'll just say when we're ready to start moving the joystick, we'll just say starting, and we'll explain the error that happened when there's the keyboard interrupt. So now let's write our while loop. It's going to be a forever loop, and then our left velocity is going to be our vertical voltage ratio. So that will be the get voltage ratio function. And then our right velocity will also be the vertical.get voltage ratio. Now my thumbstick has actually inverted the vertical direction, so I'm actually going to invert it in the code by just putting a negative sign in front. This might not be the case for you, just do whatever works. And then we are going to add our horizontal voltage ratio to our left velocity and subtract our horizontal from our right velocity. Now, the reason this is if you were to actually point this thumbstick upwards, then it would go forwards for both, but then you want one axis to slow down as you move it to the left. And a good way of doing that is just subtracting it, or actually in this case, since it's -1 right here, that you could read as -1 to 1 and then -1 to 1 on the vertical. And if it were to actually go left, you can actually just use the formula that says, hey, add this -1 onto whatever the vertical direction is. So if you were going full diagonal, then it would send that amount of power to both wheels. And then we just set our target velocity. Let's just do our left velocity for the left motors, and our right velocity for the right motors. And let's just do Python 3 code.py. We'll wait for it to connect. And now it's started, because we put that print statement there. So I'll move the thumbstick forward, and the robot should move forward. I'll move it left, and it should turn left. But now when I move it diagonally, the program stops. This is because there's a slight delay between the horizontal and the vertical direction on the thumbstick, which causes it to go against the limits of the motor, and you can see the limits are -1 to 1, so -1 being backwards, 1 being full forwards, and 0 being stopped. So let's write a function that actually handles that for us. We'll just write this below our assignments, and let's call this the motor limit handler. And we'll have our value that we pass in, so this could be the left velocity or the right velocity, our minimum value, and you can see that was -1, so we'll make it -1 by default. And to make it reusable, we'll just make it a default argument. And let's just write a quick if statement. So if the value is less than minimum, then assign the value to minimum. So it will always be the minimum amount. If the value is greater than maximum, or if it goes beyond those bounds, then just set it to maximum. Return the filtered value. And the only thing we have to change in this program is we have to just wrap the left velocity in our motor limit handler, and the right velocity in our motor limit handler. We're running Python 3 code.py. So now it's moving, and we can move diagonally without the program quitting. And it works just fine. So that's how I made a remote control rover using Phidgets and Python. If you enjoyed this video, be sure to drop a like and subscribe if you want to see more videos like this. I'll see you in the next one.